Okay, guys, can you see my screen?
I can. Take it away.
Great. So yes, as you said, I will be talking about Sprint Advanced Concept Training and how we use FreeFlyer to support that. But a little bit about myself first. My name is Stephen Paligo. I'm a software engineer in the AI Solutions and National Security Space Division, which means my focus is on helping customers, users, people who are interested in space and how it relates to national security. That's my main focus, but what that really means is that I am interested in SSA and SDA. So for those not familiar with those terms, let's talk about it a little bit. So I know this is an eyeball chart, lots of text, but it's really good information to understand understand these concepts. So space situational awareness is the knowledge and characterization of space objects and their operational environment. SSA is the practice of tracking objects in space, identifying them, establishing their orbits, and understanding the environment they're operating in, and even predicting their future positions and threats to their operations. So in practical terms, SSA is catalog maintenance. It is keeping track of everything to ensure spacecraft have the ability to perform their function, the function that they were intended to do. But unfortunately, in more recent times, that has become more difficult than it should. A couple years ago, the United States Air Force Space Command said that we need to start changing the paradigm of space situational awareness. We need to, because of the actions of hostile actors, we need to look at it in a wider context. So they released a memo that said that the implication of space fighting, or space as a warfighting domain, demands we shift our focus beyond the space situational awareness mindset of a benign environment to a more effective and comprehensive space domain awareness. So space domain awareness is the identification, characterization, and understanding of any factor, passive or active, associated with the space domain that could affect space operations and impact the security, safety, economy, or environment of our nation. So space situational awareness, which has been around for a while, this idea is being expanded by the United States and other countries into a protect and defend mindset. They're enlarging the umbrella to not only ensure that spacecraft can operate as intended, but that anything that could impact security or safety or national security issues are included as well. So hopefully, I'm used to SSA, so hopefully I don't fall back into using that all the time. I'm trying to transition to the term SDA, but if I say SSA, what I mean is SDA. So on to SACT. That's what this topic's about. So what is it? It's Sprint Advanced Concept Training, which, as I said, is SACT, and it's a very large space-focused exercise series based on advancing the state-of-the-art in SSA. It's organized by Air Force Research Lab and the Joint Task Force for Space Defense. And participants are military, civil, and commercial institutions, as well as academic institutions from all over the world. So it's a large group of people interested in SDA that get together 3 times a year with the goal of advancing the state of the art on SDA. And what happens? Well, 2 main things happen. The first is practicing SDA against real and simulated space events. So a large part of the community are operators who their job, their role is monitoring the space domain, what happens in it, and reacting accordingly. So this is an opportunity to get these people together and practice space domain awareness, practice their procedures and reactions to various things that happen. And we can do that in a controlled environment. And then additionally, the purpose of SACT is to experiment and expand the art of the possible. Participants bring in tools, algorithms, tricks, things that they've learned to try out in a in an SDA environment with a lot going on to see how they work. Is such and such the best of breed? Do they find out, if doing a certain tactic works? If using a certain tool for something, does that work? So it's an opportunity to get together to train the people to practice and experiment with the tools to improve SDA for all involved. So to practice, you actually need an environment to practice in. So how do we do it? So there are, of course, real day-to-day space events occurring. Just because we're in an exercise does not mean real life isn't happening anymore. You have spacecraft station keeping, you have the maneuvering, you have launches, you have close approaches, etc. All of these things go on day to day. And so we take that environment and then we overlay onto it other things. So we have real spacecraft and operator participation. So we will have real satellite owner operators participating. They might maneuver for us to do something that the operators need to see. They might shut off their comms to simulate an outage. They might, we actually, in a recent SACT, we had a launch provider who had flexibility in their launch window. So they decided to launch at a time that was advantageous for us to practice with. So lots of participation from the community, from real life spacecraft, and to enhance what's going on day to day. But in addition to that, we then overlay simulated events in what's called a sim over live fashion, where we take simulated events and overlay them on the real data stream. And so participants in SACT see data coming in, but they don't know if it's simulated or real. So that gives us the ability to practice things that are not really feasible, things you wouldn't want to use a real spacecraft for example, a breakup. You don't want to break up a satellite just to test how you deal with that. But with our sim over live capabilities, we're able to cause satellites to explode several times a day over the course of a week. That's something that we can do because we're overlaying that on top of the normal data stream. So examples of things you might see in SACT are conjunctions, maneuvers, reentries and launches. As I said earlier, comms outages, breakups. Something you see a lot is rendezvous and proximity operations. That's spacecraft coming nearby, perhaps for docking, for inspection, etc. GPS jamming, space weather, lots of things. They like to say that it's your worst day in space, because we can throw between what's going on, what participants are able to add in simulation. We're able to throw all these things together and do so much in the course of a week. Okay, so what things have we been able to do at SACT? So here are some recent results. One provider has released daylight tracking by optical sensors. So now they're no longer limited by nighttime, and they can track during the day. More detailed pattern of life analysis, lots of machine learning to do things like maneuver detection. Enhanced simulation capabilities, that's where we come in. More on that later. But we're able to demonstrate international ops cell coordination and handoff. So the way SACT is implemented is there are ops cells spread all over the world, and we're able to pass custody of the space events from one cell to another, hand those off, so that we can keep 24-hour surveillance on the space domain, and improve our relationships across the world, helping each other out with space domain awareness. We've done student training. If you look, the image actually in the top corner of the slide was produced by students in the last SACT. So we took the opportunity through the FreeFlyer University program that Michael Barton spoke about earlier, and got them FreeFlyer with the idea of getting students involved in what it's like in real life, to help them to know what to expect if they pursue careers in space domain awareness. In this case, they were doing conjunction analysis, I believe, using FreeFlyer. So that's a FreeFlyer display that they built and coded up and really got them involved in the effort so they can have hands-on experience with what to expect in their careers. Additionally, we've seen new SEA tools and so much more. Every SACT exercise we increase capability, and it's just astounding what people are able to do. So how do we help? What's our role as in the National Security Space Division with SACT? Well, we have a product called OBSIM, which is a high-fidelity physics-based simulation framework for space events and sensors. It uses FreeFlyer under the hood for spacecraft and sensor modeling, and it's the primary simulation provider for SACT. So doing lots of those events, overlaying the simulation over live, that's all OBSIM powered by FreeFlyer. Well, why is that needed? It's because realistic space training data is difficult to obtain. You might have data sources, data from the past, but you often can't get to it in certain environments. Maybe it's classified, maybe it occurred at a time that wasn't advantageous, and to move that data in time may be difficult astrodynamically, etc. So it's real data is often hard to get. So usually then exercises devolve into what are called tabletop exercises, where a group of people sit down at a table and literally discuss through what they would do. So they get white card inputs. Someone hands you a card saying this happened, and how do you respond to it? Well, that's not a great situation to be in. There are assumptions that have to be made. It's static, it's scripted ahead of time. And that kind of exercise doesn't really prepare operators for how they would face space events in reality. It also doesn't allow the use of tools because everybody's just sitting at a table talking. So what we did was provide OBSIM to realistically simulate space data. And now they can use that on top of their normal data streams to actually practice with things in real life using their tools at a pace that we can control, using events that we can control and create with near unlimited flexibility. So what are some of the features that OBSIM provides? You can use pre-canned scenarios or create your own from our event building blocks. So we provide a number of events that the user can string together to do whatever they want: maneuvers, breakups, RPOs, launches, etc. And they can string those together how they want. For example, you could have a launch, reach a parking orbit, maneuver into a transfer orbit, which causes a close approach, and oops, it hits something and breaks up. That's the kind of scenario that can be created with the flexibility of these event building blocks. Or you can use our pre-canned scenarios, which there are a number of them that provide more custom capabilities without the user having to necessarily do all that astro work themselves. We also have the ability to import externally generated truth data. So the user can generate data outside of the system and bring that in, and that becomes the truth. So instead of using the pre-canned scenarios or the event building blocks, you can have externally generated truth data, which can do then whatever you want, as long as you can provide TLEs or state vectors or ephemerides. Then OBSIM can bring that data in and generate observations from it. So we model existing sensor networks. So various commercial, military, government sensor assets, or you can stand up sensors from our model library. Radars, opticals, ground space, ship-based sensors are all included. We have fences, etc. Just a huge library of customization. So you can, if you want to plop down a sensor somewhere on the Earth and say, hey, what would happen if we had a sensor here? That's something you can do with OBSIM. So it gives a lot more flexibility than you would have in a tabletop exercise using those white cards as inputs. You can change sensor features, etc. There are several sensor tasking algorithms to choose from. The ability to generate realistic sensor observations, which means noisy. So we've actually done experiments where we've simulated sensor observations, and the participants in those exercises can't tell what's real and what's simulated. And so we can generate those obs in a variety of formats to, I don't want to say fool the user, but that's essentially what we're doing. Is the users need to operate as though they don't know what's simulated, and we're able to do that. ObSim is compatible with AFRL's Unified Data Library, which is a data lake that the Air Force is turning to as a central place to store all their space-related data. So compatible with that, and as I said, customize nearly everything. We can control lots of different knobs in the system to really do whatever you want to simulate the space domain and the events that are in. So here are just some of the events that we are able to simulate. Maneuvers, so many types of maneuvers, lots of maneuvers. Ballistic and orbital launches, breakup and shedding events, close approaches. We even have a user that likes to do close approaches with impacts, so you get a breakup. Deployments, docking and undocking, and you can use canned canned scenarios like rendezvous and prox ops. We support NMCs and FMCs and other things. One of our pre-canned scenarios that is used a lot is breakups with a close approach. So something breaks up and a piece then starts flying toward a target, and we craft the breakup so that that piece looks to be characteristic of all the other pieces in the breakup. So again, with the idea that you can't tell that it's simulated, it looks like real life. You don't just have a piece flying out of the breakup towards something else. So how do we use FreeFlyer? As I said, FreeFlyer is the bedrock underneath ObSim. Everything runs through the Java Runtime API. So as Michael Barton said in his presentation earlier, you can use the Runtime API to call into FreeFlyer from other languages. We use Java, and we're able to call FreeFlyer as if it were a library. We can we have mission plans that perform specific actions, and we can call those as needed. Everything is run using external or interfaces external to FreeFlyer. So we call in without needing a user in the loop. We call into FreeFlyer, have it perform an action, and return the results to other systems. We're able to use FreeFlyer for generating events and scenarios. As I said, we heavily use targeting and optimization. So for example, with the RPOs that I mentioned earlier, we're able to plan maneuvers that one satellite can maneuver around another for an inspection, for example. And we use targeting and optimization for that to plan optimal maneuvers as they would in normal life. And we run spacecraft simulations on FreeFlyer, so we can do things like propagation, force modeling, etc. And as Michael showed earlier, those things are really easy. We can propagate with 3 lines of code, you know, and so we use that heavily for our spacecraft simulations. We can simulate sensors and their characteristics, so fields of view, fields of regard, but also we can do slew and settling times. We can simulate times between observations, processing delays, etc. So really the data coming out of these simulated sensors looks real because of the capabilities that FreeFlyer provides. We perform contact analysis. So we take the models of the spacecraft and the sensors, as well as the truth data from those events and scenarios, and we see when will a satellite be in contact with a sensor? And then we can plan simulated observations, the realistic noise simulated observations, and generate all of those using FreeFlyer. Then finally, we can use orbit determination to maintain a catalog for each of the sensors as normal real life sensors would do. They maintain a catalog of the spacecraft to see when they would come in contact again and plan their operations around the states that they have for that. So that's how we use FreeFlyer. FreeFlyer is wonderful because it makes everything so easy. As I said, you can do propagation in just a few lines. We've seen users trying to develop other tools from scratch, and it takes them so much longer and so much more effort because they're trying to invent things that FreeFlyer provides us out of the box. So we have mission plans that can do all sorts of things, and they're quite simple to script up and provide rapid capabilities for OBSIM. We can develop new features in a fraction of the time because we have the tools built into FreeFlyer.
Great, thanks, Stephen. I have a couple of questions for you. Get situated here. So first question is, well, first of all, this is very cool. How do you generate a conjunction?
Okay, so we use the targeter to plan a maneuver of the interceptor with its target. So we'll use the targeter to calculate a maneuver at an advantageous time. So for example, if it needs an inclination change, we'll plan that for a nodal crossing. And we'll use the targeter to come up with when's that correct crossing, and then iterate on that to put it into a close approach within tolerances of its target.
Gotcha, thanks. You talked a lot about OBSIM and it's used in the UDL. What does the interface actually look like? Is it a command line? How does that work?
So OBSIM exposes web services. So it has a number of REST interfaces for the different services it provides, and the user can call into that with tools that can call into REST interfaces. But also we've had users build interfaces to that system because it provides that interface. We can support machine-to-machine contact. As I said, there's no human in the loop during this process, so they can. One user, for example, built an interface that calls into our services that allows people with limited astrodynamics background to schedule events without messing anything up, without having to know certain things. It's kind of an easy button for them, and they can call into that and schedule a collision, for example, something that might take, if you're doing by hand or planning it out in another tool, would take a lot more effort and take a lot of time to get right. So we provide those interfaces, and then users often provide ones custom to their needs.
Sounds like we've used OBSIM to make it almost as easy as writing it on a white card.
Yes.
And it's a real thing.
Yes, absolutely.
That's awesome. The last question is actually from our FreeFlyer team. What future FreeFlyer enhancements are you looking forward to or looking for from the team that would make OBSIM and the work that you're doing with SACT even better?
So that's a great question. I think a scheduling capability would be really good. Right now we have our scheduling for OBSIM external to FreeFlyer, but it has to call into FreeFlyer to do calculations that can't be done outside. For example, lighting or contact analysis, things like that. I think baking that into FreeFlyer would provide a lot of capability, a lot of benefit to users.
Great. If you're on the line and you also think that scheduling is something that would be useful, let us know. Mention that in the chat or contact us afterwards. We're always looking for ways to make the software better for the most people. So let us know what you're looking for in future versions of FreeFlyer, and we'll see what we can do. Thank you so much, Stephen, for your time today and for the great presentation.
Thank you.